Hey everyone, and welcome back to the channel. Today we diving deep into a topic that's the unsung hero of the digital world, intelligent system surveillance. Now, I know what you might be thinking. Surveillance sounds a bit intense, right? But we're not talking about anything creepy. We're talking about the smart, automated systems that work tirelessly behind the scenes to keep our favorite apps, websites, and services running smoothly. Think of it as a super intelligent guardian for the digital universe. So, what exactly is this intelligent system surveillance? In simple terms, it's about using technology, specifically artificial intelligence and machine learning, to monitor the health and performance of complex computer systems. Imagine a massive online shopping platform during a huge sale. Millions of users are logging in, browsing, and making purchases all at once. The amount of data being generated is staggering. How does the company ensure their website doesn't crash under the pressure? That's where intelligent monitoring comes in. Instead of having a team of engineers staring at hundreds of graphs and dashboards 24/7, these smart systems do the heavy lifting. They learn what normal looks like for the system. They understand the typical patterns of user traffic, data processing, and server usage. It's like they get to know the system's personality, when it's busy, when it's quiet, and how it behaves under different conditions. This learning process is crucial. Traditional monitoring systems were often based on simple, fixed rules. For example, an engineer might set an alert to trigger if a server's CPU usage goes above 90%. That sounds reasonable, but it has a lot of problems. What if it's perfectly normal for the CPU to spike to 95% for a few seconds during a specific daily task? With a fixed rule, engineers would get a false alarm every single day. This is what we call alert fatigue, and it's a huge issue. When people are constantly bombarded with meaningless alerts, they start to ignore them. And when a real, critical alert comes through, it might get lost in the noise. This is where automated anomaly detection changes the game. Instead of relying on rigid, predefined thresholds, these intelligent systems use machine learning algorithms to identify what's truly unusual. An anomaly isn't just a high number, it's a deviation from the established normal pattern. For instance, the system knows that website traffic usually peaks around lunchtime. So, a massive, unexpected surge of traffic at 3 a.m. That's an anomaly. A server that's supposed to be communicating with another server suddenly going silent. That's an anomaly. The time it takes for a web page to load suddenly doubling for no apparent reason. You guessed it, that's an anomaly. These systems are incredibly sophisticated. They don't just look at one metric in isolation. They analyze hundreds or even thousands of different data points simultaneously, looking for correlations. Maybe a slight increase in database errors combined with a small drop in user logins does unseem like a big deal on its own, but the AI might recognize this specific combination as an early warning sign of a major database failure that's about to happen. It's like a seasoned detective noticing tiny, seemingly unrelated clues that everyone else missed and piecing them together to solve the case before the crime even happens. The ultimate goal here is rapid response. The sooner you detect a problem, the faster you can fix it. When an intelligent system detects an anomaly, it doesn't just send a generic, confusing alert. It provides context. The alert might say something like, unusual spike in login failures detected, correlated with high memory usage on authentication server X. This pattern has previously been associated with a 90% probability of a system-wide login outage within the next 15 minutes. Wow, think about how powerful that is. It doesn't just tell you something is wrong, it tells you what is wrong, where it's happening, and what the potential impact is. This allows the engineering teams, often called Site Reliability Engineers or SREs, to spring into action with laser focus. They don't have to waste precious time digging through logs and dashboards trying to figure out the source of the problem. The intelligent system has already done the initial investigation for them. This leads to a massive reduction in what we call mean time to detection, or MTTD, and mean time to resolution, or MTTR, in the fast-paced digital world. Every second of downtime can mean lost revenue, frustrated customers, and damage to a brand's reputation. By catching issues before they escalate into full-blown outages, these systems are worth their weight in gold. Let's think about a real-world example. Imagine a popular streaming service on a Friday night. Suddenly, thousands of users start experiencing buffering issues. With a traditional system, it might take a while for the support team to notice the trend from customer complaints. Then, engineers would have to manually investigate everything: the network, the content delivery servers, the application code. It could take hours to pinpoint the root cause. With an intelligent monitoring system, the moment the buffering issue begins, the AI would detect a deviation. It might see an increase in video playback errors, a slowdown in a specific microservice responsible for delivering video segments, and an unusual network latency pattern from a particular cloud provider. It would correlate these events and immediately alert the on-call engineer with a precise diagnosis. The engineer could then, for example, reroute traffic away from the faulty provider or restart the struggling microservice, resolving the issue for millions of users in minutes, not hours. Many users might not even notice there was a problem at all. That's the magic of proactive, rapid response. And it doesn't stop at just detecting problems. The next frontier is automated remediation. In some cases, the system can be empowered to fix the problem itself without any human intervention. For example, if a server becomes unresponsive, the system could automatically restart it. If a database is running low on disk space, it could automatically archive old data to free up room. Of course, this requires a high degree of confidence in the AI's decision-making, so it's usually reserved for predictable and low-risk scenarios. But as the technology gets smarter, we'll see more and more of this automated self-healing. So, who uses this technology? The short answer is almost every major tech company you can think of. E-commerce giants, social media platforms, financial institutions, streaming services, and cloud providers all rely heavily on intelligent surveillance to maintain the stability and reliability of their services. For them, it's not a luxury, it's an absolute necessity. The scale and complexity of their systems make manual monitoring completely impossible. But it's not just for the tech giants anymore. As cloud computing has become more accessible, even smaller companies and startups are now running sophisticated applications that require robust monitoring. The good news is that the tools for intelligent monitoring have also become more accessible. There are now many platforms and services that offer AI-powered anomaly detection, making this powerful technology available to a much broader range of businesses. This field is also constantly evolving. Researchers are developing even more advanced machine learning models that can predict future problems with even greater accuracy. They are working on systems that can understand the logical flow of an application and automatically identify bottlenecks or design flaws. The ultimate vision is a truly autonomous system that not only monitors and heals itself, but also optimizes its own performance and resource usage over time, all without a human lifting a finger. So, the next time you're effortlessly streaming a movie, buying something online, or scrolling through your social feed, take a moment to appreciate the silent guardians working in the background. These intelligent surveillance systems are the backbone of our modern digital infrastructure, using the power of AI to detect anomalies and enable rapid response. They are what make the seamless, always-on digital experience we've all come to expect possible. It's a fascinating intersection of data science, software engineering, and artificial intelligence, and it's only going to become more important as our world gets more connected. Thanks so much for watching today. I hope this gave you a better understanding of what goes on behind the curtain of the apps and services you use every day. If you found this interesting, please hit that like button and consider subscribing for more deep dives into the technology that shapes our world. Let me know in the comments if you have any questions or if there's another tech topic you'd like me to cover. Until next time, stay curious.